Welcome to Bio 3 again. Today is first Tuesday, week 2 lecture. We will talk about general chemistry, including the atom, element, and matter. Before we start, let's have a review of what we learned from last week. Last week we learned about the definition of biology. We also learned about the 7 characteristics of living organisms. Last but not least, we learned about scientific method. So, if you have watched the video about the characteristic of life, then you should, I hope, you remember the level of organization of a living organism. What is the level of organization of a living organism? Remember, let me ask you this question. Okay, what is the largest level, the highest level of organization of the organism? The highest level, we call it biosphere. Biosphere is basically the entire Earth, so we call it biosphere. And let me ask you a definition. What is the basic subunit of life? What is the basic subunit of life? And the answer is should be cell. So what happens when we break down cell? When you break down cell, you will get molecules. If you break down molecules, you will get atom. So that's why today we talk about atom, from the smallest first, and then we will gradually move on to larger and larger. So this is the definition of matter. Anything that takes up space and weight, but I don't really like the word weight because weight will change. If you are on the Earth, then you have certain weight. But if you go to the moon, you'll be significantly lighter because the weight depends on the gravitational force of that planet. So the weight will change. I don't like this definition because of this reason. Your weight will change depending on which planet you live in. So if you live on the moon, then you have a light weight. If you live on the Earth, you have your current weight. But if you live on Jupiter, let's say Jupiter, then you will be extremely heavy. That's why I like the term mass. Mass is something that will not change. So if you have a certain mass on the Earth, you still have the same amount of mass on the moon, and you still have the same amount of mass on the planet Jupiter. So mass is something that will not change, and I like this definition better. You'll see the definition of matter using mass later in the slides. And there are 3 stages of matter: solid, liquid, and gas. Very simple. It's like water, ice, water, and water vapor. And solid, liquid, and gas, I want to memorize the 6 or 7 terms here, because I guarantee that I will test you in the exam. So when solid becomes liquid, it's like when the ice becomes water, we call it melting. That is common sense. The ice melt to become water. But when water becomes ice, we call it freezing or solidification. So either term, I'll take it as correct answer. And then you have from liquid to gas, is this evaporation. It's like you are boiling water and the water becomes a water vapor. Well, from gas to liquid, we call it condensation. For example, you have water with vapor coming out from a boiling kettle. And then you put a piece of glass on top of those water vapor, and then the water vapor will so-called condense on the surface of that glass, that become liquid on the glass. We call this condensation. And then from gas to solid, that means from water vapor directly to become ice, which we seldom see from our daily life. We call it deposition. From solid to gas, from ice directly into gas, we call it sublimation. That takes a lot of energy. Yeah, you have to supply a lot of energy in order to have sublimation. Because a solid to gas is basically you bypass the liquid state. So in addition to the three states of matter, solid, liquid, and gas, there's a fourth state, we call it plasma. Plasma, we call it ionized gas. What it means is that if we supply more energy, to gas, if we hit the gas even stronger, then the electron around the atom of the gas will come out, become something called unbound electron. When the electron come out from the atom will become either a positively charged ion or negatively charged ion. And in this case, we call this plasma. We can find plasma in stars or the sun, but we seldom see plasma from our daily life. Another definition of plasma that you will see, you will learn from biology or anatomy or physiology is from blood. When you have blood and then you remove all the blood cell, remove red blood cell and white blood cell from the blood, then we call that plasma. So, but in this part of the course, the basic chemistry, when we talk about plasma, it is referred to the ionized gas. So I like this definition about matter because it's anything that takes up space and has mass. Mass is the key word because mass is something that doesn't change no matter where you are in different planet. And living or non-living is made up of elements. So we'll talk about what element is now. So what is element? Element, they are the substances that cannot be further broken down. I find that it is a little bit confusing. We are talking about atom, and then suddenly we go to elements. So what's the relationship between atom and element? So atom is also something that you cannot further broken down. If you break down atom, it becomes a proton, neutron, and electron, which is something that we'll talk about in the next few slides. And then atom, you have different types of atoms. For example, you have carbon atoms, you have nitrogen atoms, you have oxygen atoms. And we call these different types of atom, we call these elements. So that's the relationship between element and atoms. And there are 92 naturally occurring elements, and you can find them from something called periodic table. And here you can see two video about elements. If you have time, I strongly encourage you to watch them. It helps you to understand what elements are. Okay, this picture is taken directly from your textbook. I want you to focus on this graph here. This graph is kind of small here. I'll show you a magnified version in the next slides. Basically, it talks about the relative abundance of the element in your body and on the earth. So in the living organism, it is red. On the earth, it is in blue. So you can see that it is much larger. Since we are studying biology, let's focus on the red bar, the elements in our body. The four most abundant elements, they are oxygen, nitrogen, carbon, and hydrogen. As you can see that the red bar, these four are the highest among all the rest of the element. And how do you memorize it? Let me introduce your new favorite Asian friend from now on. His name is Chong. So Chong will be your new favorite Asian friend from now on, because his name reminds you the four most abundant element in our body. So if I ask you this question in the exam, give me the four most abundant element in our body, then you should immediately know that Chong: carbon, hydrogen, oxygen, and nitrogen. If I ask you what are the six most abundant element, what are the fifth and sixth most abundant element, if you look at this graph here, you'll see that calcium, the red bar is relatively high, and then the rest of them, they are pretty much the same, but I can assure that the sixth one, the fifth one is calcium, the sixth one is phosphorus. So this is what is shown on the graph. And guess what? How do you memorize this? First of all, you can use this trick or mnemonic. Captain Chong. Yes, it is not Captain America, it is Captain Chong. So calcium, phosphorus, and then carbon, hydrogen, and oxygen. Captain Chong. It will help you to memorize the six most abundant elements in our body. However, your textbook has an inconsistency or discrepancy. So in your textbook, we saw that from the picture, it tells you that the six most abundant elements, they are Chong, and then it is calcium and phosphorus. But what about if you read the text word by word? It tells you a different story. It tells you that the four most abundant elements, they are carbon, which is consistent with our what we saw from the graph. Hydrogen, it is also consistent with the graph. Nitrogen, which is also consistent with our graph. Oxygen, also consistent with our graph. So you can see that Chong is here. You can see Chong here. What about the fifth one? The fifth one, they said that it is phosphorus, which I think it is also consistent because captain, P. And then what about the sixth one, the last one? The last one, they said that it is sulfur, which is, or I would say, inconsistent with the graph that they show on the textbook. As you can see from the graph, calcium is much higher than sulfur. So I don't understand why they put sulfur higher than as the sixth one instead of calcium. Personally, I would take calcium as the highest one because our bone are made of calcium phosphate. That means it has calcium and phosphorus. I prefer calcium. Since our bone are made of calcium phosphate, and here is set that by weight. As you know that our bone is quite heavy, and where can we find sulfur? Sulfur we can find in protein. Almost all protein has sulfur. An example is that we can find sulfur in our hair. I'll talk more about the sulfur in the hair later. Since our bones are made up of calcium phosphate and our bones they are extremely heavy, so I personally take calcium as the one of the 6 most abundant elements in our body. So just to make it clear, in the exam, if I ask you what are the 4 most abundant elements in the body, it will be Chong. But if I ask you Chong here, but if I ask you what are the 6 most abundant elements, it will be calcium and phosphorus. Is that clear? So at